final presentation this morning is going to be from Priti Patel. Priti is our Vice President and Chief Transmission Officer. With more than 28 years of electric utility experience, Priti oversees Great River Energy's transmission business. Her responsibilities include oversight of all aspects of transmission, including investment strategy, planning, permitting, construction, maintenance, engineering, project management, and field and system operations. Prior to her current role, she held leadership positions at Xcel Energy and the Mid-Continent Independent System Operator, MISO, who you've heard quite a bit about this morning. And you've also heard quite a bit about generation. This presentation is really going to focus on the other area of our business in the transmission focus area. And there's equally exciting evolutions taking place in transmission that we're excited to be a part of and are critical to our progress that's being made on our energy transition overall. Priti, are you there?
I am. Can you hear me?
Yes, we can.
Great. Is my face blown up on a screen?
You are larger than life right now, so.
Oh, great. Wonderful. Well, thank you. And thank you for the invitation to Lake Region and to Lake Region's leadership. You know, I will say that it's always hard to be the one that this audience has to listen to as your stomach is probably growling, waiting for lunch. But hopefully the topic is as entertaining to you as it always is to me, and that it can sustain you. And thank you, Jeff, for the very nice introduction. So this year, what I'm going to do is I will talk about the expanding role of the transmission grid, but I'll also talk about some of the big questions that we're fielding as they relate to just, the Trump executive orders, tariffs, supply chain, public engagement, really hot topics when you think about what you need to get into the ground to continue to maintain reliability going forward. So I will say in the end, not a lot is changing when it comes to the transmission build out that's needed, that I've talked about over the years at this forum. We're just encountering some more headwinds, some challenges that we really do need to proactively prepare for. Next slide, please. So as Zach has mentioned before, we are Lake Region's G&T cooperative, Great River Energy. We provide wholesale power and transmission services to Lake Region. We are owned by Lake Region and 25 other members, and when you combine us, we really, we serve about 2/3 of the state from a geographic perspective. It's always nice to see the fact that we've got over 5,000 miles of transmission, over 109 different substations that we use to serve our membership. And over the years, we have really grown a robust system of transmission in Minnesota, and we've got a little bit in North Dakota. And when you look at our service territories, they are predominantly rural and suburban. And on average, we have 7 customers per line mile, which is important for us to know because it puts reliability and affordability at the forefront, right? We are hyper-focused, as Zach mentioned, on delivering nation-leading reliability while we continue to keep our rates low, over 20% below the national average. Next, please. So as many of the other speakers today talked about, we continue to be in this midst of this fundamental transformation about how power is produced and how it's being consumed, right? So utilities like Great River Energy and cooperatives across Minnesota, the upper Midwest nationally, they're changing their generation mix, whether it's based on economics or state policy. It is happening. And our loads are changing. We're seeing pockets of impacts from electrification, onslaught of data centers. Loads are showing up like brand new little cities across the country. And as generation resources and demand evolve, the grid, the transmission grid has to as well. How we design it, where we locate it, how big it is, it has to continue to be the great enabler. And it is still the linkage between power plants and our communities, which consume electricity. And the scale and magnitude of this grid transformation is frankly unlike we've seen in our lifetime. We draw strong parallels to the original electrification of the nation in the early 1930s. And what you see on this slide are 3 significant major transmission build-out phases that are currently under development in the Midwest, in the MISO footprint. And Zach talked quite a bit about MISO and the geographic footprint that we, GRE, and the state of Minnesota are a part of. And so in total, when you look at all of these phases, it is going to add 6,500 miles of new transmission. In Minnesota alone, we will add 1,400 miles of new transmission. And this is all high voltage and extra high voltage, which I'll talk about. So we're talking, 345 kV, which is native to our state, but also 765 kV, which is not native. And these phases, and MISO calls, as you can see on the screen, tranches, tranche 1, tranche 2.1, and then you've got something called a JTIQ, which is really trying to connect regional transmission organizations or regions for more efficiency. What this is doing is it's showing you the evolution in how we're planning our transmission grid. So it's evolving into large scale, more interstate transmission projects versus smaller, maybe less efficient transmission lines. And the goal now, as you can see on this slide, is really to efficiently move large amounts of power across the region, right? Where and when it's needed. And it's these regional backbone projects that are really going to enable local load serving projects that we have in our communities to continue to deliver reliable power directly to customers. So we need all of this. GRE in Tranche 1 has a number of projects that we are owning and developing. And in the middle graph, you see Tranche 2.1. We have 3 Tranche 2.1 projects that we own and are helping with development. It's in the northern part of the state where you see that red V, sideways V. Those are 2 of the projects. And then the green line you see in southern Minnesota, we own a portion 50% of that project in southern Minnesota. And that's a 765 kV line, which I'll talk about. But let's go to the next slide. So along with those more interstate projects that we're engaged in that I just showed you, I always like to show what GRE is doing when it comes to the reliability of Lake Region's area and its customers, where we see needs and issues on the horizon. So the build out of the regional high voltage transmission lines that I just showed you on the previous slide, they also directly support the reliability of Lake Region's communities. There is a connection. So as you can see on the map on the right, 2 of the MISO approved projects from Tranche 2.1, Maple River to Cuyuna that you can see, and Bison to Alex to Big Oaks. Those are in Tranche 2.1. They traverse Lake Region service territory, and they do provide significant grid benefits and backbone reliability to Lake Region members. These projects, when you think of these regional high voltage projects, they work together as a grid to help move energy across the Midwest into communities like Lake Region where it's needed. And so it's a lot like our nation's highway system, if you think about it, right? We rely on interstates to move freight and passengers over long distances. Same thing with the power grid. You need high voltage transmission to carry electricity efficiently across regions. So this helps the county highways and the local roads, like our lower voltage transmission network, to handle that final leg of the journey with less congestion, so better energy prices, and ensures that power can freely move and flow to its final destination. So not only are we working with MISO to upgrade the regional transmission system, but if you look to the map on the left, you'll see that Great River Energy Transmission is always working to maintain and enhance the lower local voltage transmission system in Lake Region's area. So that's the 34.5 kV or the 69 kV or the 115 kV systems that directly serve your customers. And in the last 2 years alone, we completed around 18 projects in the Lake Region area to address needs that were associated with Otter Tail's Hoot Lake plant, retiring, some load growth that you're experiencing, age and condition of some of our existing infrastructure. And we've got 5 more projects that are underway in the Lake Region system to help bolster reliability. So, making sure we're upgrading aging assets, replacing transformers, switches, rebuilding 25 miles of transmission. And when you think of the 2020 decade alone, SHRE will have invested over $100 million in Lake Region system. So we take reliability seriously. Next slide. So with all of this development that we have forecasted with transmission, especially a lot of the big build that is going on, I do get a lot of questions. Why is there such a significant need for more transmission? Can't we just better use what we have today, the existing system? Do some of the recent Trump administration executive orders change the need for transmission? Is coal going to make a resurgence? Is it going to displace other generation? Is renewable generation going to stall out? What's the public reaction to all this? Well, we've spent, 4 years engaging with local communities on a number of projects recently. What's the vibe, and what are you doing about community engagement? And then tell us about what the impact of the tariffs are. And they're always, really good questions. So let's go to the next slide and talk about why so much transmission that is new is needed. Next slide. So I can't emphasize enough how all of these factors that you see on the slide are really driving the evolution of the transmission grid. And a lot of speakers have spoken to this already. We all know that the generation mix is changing. Coal used to be the backbone of power supply since the 60s, and it continues to retire. Over a decade ago, the majority of Minnesota's energy needs were met by coal plants. As we look toward the next decade, we doubt if any of our energy will be met by coal-fired plants. And as we look ahead, our energy supply as we look ahead is going to be primarily driven by, wind, solar, which are not only weather dependent, but they're geographically dispersed. Gas is likely to be a supplemental peaking resource for reliability when the wind doesn't blow and the sun doesn't shine. And we're also seeing demand patterns shifting, right? So over the last 10 years, we've had relatively flat growth. That's not the case. And you've heard this from other speakers. We're seeing renewed growth, a lot on the horizon when it comes to electrification and data centers. And we're receiving, GRE itself is receiving requests to study data centers that have loads between 500 and 1,000 megawatts at a single site. That is pretty significant for our cooperative. So with all of these aspects that you see changing, the one thing that doesn't change is the need for reliable power. And that means we have to maintain and improve the transmission that we have today, but also we do have to build new transmission to keep up with those demands. Next slide. So the pace of change is staggering. So this is really, I think the pace we have seen over the years is really fast for an industry that is capital intensive and provides a life or death service, right? A critical service. Throughout history, we have seen inflection points of how energy is produced, how it's used, and how it's resulted in step changes when it comes to the transmission grid itself. So the last inflection point that we experienced was in the early 2000s. And I remember it kind of like it was yesterday because I was helping lead a group of 11 utilities that ultimately developed the transmission build-out solution to meet the needs that were ahead of them. In early 2000s, Minnesota had passed its first renewable portfolio standard, 25% by 2025, which combined with many other factors resulted in the need for 25 gigawatts of new generation that needed to be interconnected across the Midwest. And for perspective, Minnesota's total gen today is around 20 gigawatts. So MISO had just been formed at that time as the regional transmission operator, and it really prompted a change as to how we plan the system and how we develop the system. So we started thinking about transmission not just being limited to intrastate transfers between neighboring utilities, but more to interstate transfers of electricity, because we found that it would lead to better utilization and efficiency. And around the same time that MISO was created, that we had a number of utilities that a few of us led in the upper Midwestern states that identified, hey, we're going to need to transfer 1 to 3 gigawatts of more energy into the state to meet our reliability needs. We saw that load was growing, but we couldn't just, we were maxing out on the small Band-Aid transmission solutions that maybe we had done in the past. So we banded together, we created CapEx 2020, and we created our solutions, which were 700 miles at that time of new 345 kV in the upper Midwest. And it was huge. It was a huge deal at the time. So I don't want to underplay its significance. But that said, when you compare then to what our needs are now and into the future, they're pretty staggering, right? Over the next 20 years across the MISO footprint, we need to connect around 116 gigawatts of new capacity and, potentially retire 100 gigawatts of fossil fuel. This is at a scale of evolution that we really haven't encountered. We need to be able to move tenfold the amount of energy through a power grid to meet our needs. And this is why it's really this evolution and transformation that's requiring more transmission to be planned and developed and built. Next slide, please. So when we add transmission, we don't take it lightly. It's like Jim Matheson said in the beginning, right? It is, we create, durable long-term plans. We study the situation, we iterate, we analyze, we look at what the most optimal transmission is so that there is no regret later, that it's meeting our needs today and tomorrow from a regional and local perspective. So if you look at a project that we're developing in partnership with Minnesota Power called the Northland Reliability Project, it's a high voltage 345 kV line. It goes from Grand Rapids area into St. Cloud, so northern part of the state, and it is to provide regional reliability support. But more importantly, is that it supports reliability in northern and central Minnesota, and reliability in the north part of the state has historically been supported by large coal, which is Boswell. But in the next decade, that plant is expected to cease operation. And this new high voltage line that we are constructing starting this fall will allow that transition to happen in a reliable manner, because it will allow power to be able to flow into the northern part of the state from the southern part of the state. And at the same time we're building this line, we're also looking at how load needs might change within the northern part of the state. And we're making sure that our transmission project has some flexibility to accommodate that load growth, right? So these are the things that we are always focusing on. Next, please. So like I said, the current build out is really being driven by changes in how energy is being produced and how it's being used. And as we are all aware, 2025 has brought, a different administration into Washington, DC, with a number of different energy priorities. But we get asked, do we expect all these generation fleet changes that we've been experiencing to continue with this new presidential administration and some of the executive orders? And I would generally say, I think we're going to continue to see these changes continue. And, let's just take a step back for a moment. So when you look at the last 25 years and 4 presidential administrations, and you can see it on this chart, we continue to see and experience a steady increasing trend in renewable additions, whether they're installed or projected, fossil fuel retirements in the upper Midwest. The administrations have been both Republican and Democrat with differing policy views. For example, President Barack Obama passed the Clean Power Plan in 2015, a plan where everyone thought, would really accelerate fossil fuel retirements. 2019, President Trump, during his first term, repealed that plan, And everyone thought it would decelerate fossil fuel retirements. And at the time, we got the same questions we have today. Will renewables stop being developed? Will coal make a comeback? But it hasn't necessarily played out that way. The result is under both administrations, you see retirements, additions of renewables continue at relatively a constant pace of what we thought the trending would be. And why is because generation trends are not just driven by policy, but they are driven by economics, right? Utilities are obligated to make long-term decisions based on resource needs that are the most cost-effective for their customers and their members, regardless of who is in office. So we also get the questions of, well, we need to build, will we need to build out all those MISO tranches that I showed you on that slide, especially the recently approved one at $21 billion in light of what the current administration is signaling when it comes to wind, when it comes to coal? And our answer is still yes. These tranches continue to be relevant and needed. And I can tell you that the assumptions that are driving Tranche 2.1, that $21 billion portfolio, they err on the side of being conservative because MISO stakeholders like GRE and others know that whenever you develop a portfolio, it has to withstand political changes in Washington. And the assumptions that we use in transmission planning when it comes to generation, a lot of them are rooted in state integrated resource plans. The states have a lot of policy autonomy when it comes to energy policy. Individual states approve their utilities, generation plans, and utilities in states like Minnesota, Illinois, Michigan, they still have to comply with their state's 100% carbon-free goals. Federal energy policy doesn't impact that. Another important consideration that underscores the need for significant transmission build-out, continued build-out, is that the assumptions that were used by MISO that led to that large portfolio were, they were based on a lot of base load growth was assumed that included firm and committed growth from data centers, which at the time was not a lot. But today, MISO and the stakeholders are predicting that data centers could have upwards of triple the demand. And that's not represented in those models that produce those large transmission portfolios. So there's going to be a need for more generating capacity, as others have talked about today, to serve those data centers. And in fact, it's one of the drivers that the Trump administration has articulated as a reason to slow down some of the coal retirements. If there is more demand and there is more generation, well, the need for Tranche 2.1 actually becomes greater because the assumptions were much more conservative than what we're seeing today. So even now, we have little reason to believe that much different will happen. We're going to see some ups and downs when it comes to some generation resources, absolutely, but we believe the general trajectory is going to remain the same. Next, please. So the need for new transmission is clear, but that doesn't necessarily mean it's going to be easy to get into the ground, right? So understanding why it's needed is one part of the story, but the next challenge, and I would say our responsibility, is how we build it in a way that minimizes impacts and when it comes to our communities and how we serve our communities, and we need to be proactive. Next, please. So we do have a number of principles that we actually adhere to when it comes to our approach. When it comes to community engagement, we don't just check the boxes. We need to build relationships. We're building, we plan to build voltages that have not been experienced in our state before. And, this is going to take time and community engagement. And in Minnesota, to Jim Matheson's point, we did have permitting reform. So we do have tight timeframes to file our regulatory permits when it comes to those big MISO projects. And so engaging early and often with our communities is becoming more mission critical because of that tight timeline. We know we need to meet everybody where they're at, and we're really using a mix of tools to make sure people are involved and stay informed. Second, we're engineering transmission infrastructure with our communities in mind. So we always start out with our overarching mission is reliability, but it has to end with minimizing disruption. So our engineers are designing systems that reduce impacts, and I'll talk about that in a little bit. And then, of course, stewardship. That is, we are a cooperative that is owned by cooperatives. So it's entrenched in our ethos. We don't just build in communities, we build with them. And it's a team sport, and we really view local government, landowners, interest groups as true partners to us when we're building transmission infrastructure. Next, please. So we have lived those principles pretty recently with the Northland Reliability Project that I mentioned, from Grand Rapids to St. Cloud in the north part of the state. The engagement approach that we took on has, I've heard a lot of kudos given to GRE from state regulators, our utility partners, and our members, and how we've approached engagement with this, high voltage line in the state. Our work has set a high bar, and we tend to treat that as our floor, not our ceiling, when it comes to future projects. We partnered with our member cooperatives along the route to help us carry the message collectively of why we need this transmission line. We wanted to do it in an authentic, community-rooted way. We hosted 22 different open house workshops across 3 rounds. Over 500 different attendees came in person. We modernized our engagement approach, so we met people where they needed to be, on-demand virtual workshops. We had an additional 350 folks join us for that. We advertised using every tool in our toolbox, traditional print, radio, social media. We offered every county, township, interest group, ATV club or snowmobiling club, any one-on-one they wanted. And we stayed true to our word. Any landowner that wants a one-on-one will make that happen. So our engagement may not have been perfect, but our approach did work really well. Next, please. One way we are minimizing impacts to our communities is to squeeze every drop of capacity that we can out of our existing transmission grid that's in place. We view that as our obligation to our membership that is paid for the existing transmission. So we have been piloting and implementing a number of different technologies so we can maximize the capacity of our transmission system. And I'll just mention a couple. Last year, we partnered with Heimdall Power on a pilot project so we could get a better and more accurate understanding, real-time understanding of what is the actual capacity on the transmission line. And in some instances, us knowing that allowed us to flow much more power on the line than we did before. So we've installed these sensors that were developed by Heimdall Power on a number of lines that we knew were congested in Minnesota. And with the data that the sensors provided, it allowed us to safely increase the capacity on because it looks at a number of factors that impact the capacity, like weather factors, temperature, wind speeds, sun radiance, all of those impact how much power can flow on a transmission line. And the more we know, the more we can increase the capacity or decrease it, depending. So right now, our testing on a number of lines that we are testing has shown that we can increase the capacity by anywhere between 30 and 50%. So the results exceeded our own internal expectations, and now we're starting to look at other areas on our system that we can expand this use of some of these sensors. A second thing we're doing is we are working with all of our neighboring utilities in Minnesota to study the entire lower voltage system as a whole and see where on the grid can we reduce congestion through effective, cost-effective fixes that we can make in the next 1 to 3 years. The more we reduce congestion, the better it is for customers to receive lower cost energy, and we understand that. And finally, when we're routing new projects, we're trying to use existing corridors to the greatest extent that we can. And we call this co-locating. And that means either we're going to put a transmission line parallel to an existing transmission line in the same corridor, or we're going to rebuild a new transmission line on common towers with existing infrastructure. So those are ways that we are really trying to lessen the impact in our communities. Next, please. So while we're doing that, when it comes to our existing infrastructure, I will say, as I've talked about, the future needs far exceed what can be done with existing infrastructure. We also need new transmission lines. So it's an and, it's not an or. And so when we look at the magnitude of the transmission needs in our region, and this gets to tranche 2.1, which I showed you early on the map, but when we evaluated how much impact, when we looked at the system and we looked at what it would take to match what would be needed, it would take a number of 345 kV lines, or we'd have to figure out a different approach. So we looked at the impact to our communities of all those 345 kV lines, and we knew that we needed a different approach. We looked at, we started looking at 765 kV, and when we think about GRE and our membership geographically covering 2/3 of the state, we know that with 345, our communities are going to be overburdened by new infrastructure. And that's why we started looking at 765 kV. So as you can see on this slide, one 765 kV line has the equivalent capacity of 6 single circuit 345 kV towers or 3 double circuit towers. And each 765 kV line is generally around the same size as a double circuit 345 kV tower. So without the 765 superhighway that we propose and other MISO stakeholders propose and MISO board approved in that slide that you saw for tranche 2.1, without that, we would need so many 345 kV high voltage lines, and there would be many times the land and public impacts to move the same amount of power. We need additional capacity to transfer over 10 gigawatts. So it's been one of the main reasons we supported a 765 kV build out. We are leading the first 765 kV transmission line build out in partnership with Xcel Energy and ITC Midwest. We're going to lead the development of 765 transmission backbone across southern Minnesota, which I showed you on that earlier slide. This will be the first 765 kV line in Minnesota. It's going to be about 2,000 miles of, it's less than that, but I can say that, there's been about 2,000 miles of 765 that's been reliably and safely operating in the US for decades. But this will be the first time it enters the state of Minnesota. Next, please. So, number of us do have the tall task of developing these, pretty important large transmission projects that carry price tags that are not just in the millions, but the hundreds of millions and frankly, billions over the next decade. And with that responsibility does come some opportunity where we can provide some significant benefits to the communities that we serve. And so with this in mind, we've developed a strong set of principles around sourcing and labor. We start local wherever we can. We make it a priority to work with our contractors that are based in the upper Midwest. We know that local dollars help build local support for these projects. Good jobs are a part of the value that we bring. So we do prefer union labor or contractors that pay prevailing wages. It helps ensure high quality work, and we want to support skilled labor in our region. We buy close to home and we scale from there. So our sourcing hierarchy starts with local and expands to the US-based suppliers, and then only go international when it's absolutely necessary, and I'll show you some of that. Compliance for us is not a checkbox, it's a baseline. We hold our suppliers to pretty strong standards: health, safety, insurance, environmental protection, cybersecurity. And in fact, on one recent project, we rejected a major contractor because of its safety record. Diversity strengthens our supply chain, so we do actively seek out certified diverse suppliers. Next, please. So it's one thing to plan the right projects, and it's another thing to get them into the ground on time. Today's supply chain environment is pretty challenging, and it is providing some headwinds that we're facing. So let's go to the next slide. So, we do have a stretched supply chain, admittedly, since COVID, actually, GRE and utilities and cooperatives, across the country, and you all have heard about this, we face pretty persistent supply chain headwinds. And what started as pandemic related disruptions to both manufacturing and shipping has now evolved into a broader issue of limited supply. And it's frankly been exacerbated by the pace and the record level of investment that people are making across the globe when it comes to transmission infrastructure. So as you can see here, critical components for substations, which, substations are the brains of transmission, of the transmission infrastructure. But the critical components for subs to develop high voltage transmission, the lead times for critical components like transformers, breakers, reactors that you see here have nearly doubled or tripled. And as you can see here, the costs have gone up alongside of them. So there's so much that is happening, so much build that is happening simultaneously that the demand is really outpacing supply. And for a lot of material that we need, the lead times that we once estimated in months, frankly, we're now estimating in years. And there's not a lot of ability that we have to expedite this as well. They vary across, as you can see, the equipment type, but you're just seeing increases across the board. And the small silver lining, and it's not the silver bullet, is that we have seen supply respond to increased demand. They're working to increase their capacity to match demand, but that is not going to happen overnight. Like, it's going to take a while for that to happen. Next, please. And on top of the supply chain pressures that we're already seeing with what we call our native voltage projects, our lower voltage projects that are in more of our communities, like 115 or even 345 kV. Once we start developing 765 kV, that's taking supply pressures to a new level. So as you can see here, domestic supply for what we need for our 765 transmission project in southern Minnesota that I showed you on a map earlier, it's really limited. A lot of the key equipment for 765, breakers, transformers, reactors, they have to be sourced internationally. There simply are not enough US-based suppliers, and the production capability is limited. So we see longer lead times, less flexibility. So we're dealing with, longer procurement timelines. We've got a lot of shipping logistics, fewer options if a problem happens. And adding to the headwinds is recognizing the fact that we're not the only ones building 765. It's being built across this country and the entire world. China is currently outbuilding the US 3 to 4-fold. And everyone relies on these same vendors that you see on the slide. And that's why the early planning that GRE and other utilities do, is really important. So we're mindful of the in-service dates of all of our projects. Right now, for these big high voltage projects, it's 2032, 2034. So we have to forecast and procure years in advance to secure production slots. And we build good, strong relationships with these vendors as well. So next slide. So some of our short-term strategies are, like I said, early procurement of key materials and equipment, getting those slots in early, staying ahead of delays and possibly pricing swings. We've expanded our spare materials program so that we've got emergency inventory in stock. We're using scale to our advantage. So we're trying to work with others to see if we can, in a legal way, to see if we can leverage situations and have larger project packages that can help us secure timing of supply and availability of materials. Longer term strategies are, we monitor our existing equipment so we can see early signs of failure That's a good thing, right? So we're enhancing monitoring our equipment so that we can anticipate failure and then procure equipment before a failure happens. We're looking at larger warehouse space. We've got mutual support arrangements that we are participating in, even more so to provide backup for us during an emergency. So these are things we are proactively doing to deal with some of the challenges and headwinds that we are facing. And so next slide is really my last slide. And I would just say, as someone who is, I guess, wrapping up the morning, and into early afternoon, is all the presenters, we've all talked about what it takes to have a reliable system. Everything we do in transmission, from engineering to engagement to procurement to project delivery, all of it, everything we do is in the service of a reliable electric system for the members that we serve. We're aware of the risks, from tariffs to supply chain disruptions. And so we are building with our eyes wide open and proactive preparation. So thank you for your time and attention, and certainly open to whatever questions come up during the Q&A.